To make this into a more suitable form for a neural network, we need to flesh out some more details. Suppose xi are from a set I xi1, xi2 up to ximi, which means each xi can take values from 1 to mi, some I mean xi, xi1, xi2 up to ximi, and suppose y belongs to the set y1, y2 and yk, which means p of y given x will model a multi-class classification problem if k is greater than 2. And suppose a is just a realization of x, the x vector. A realization of x, which means a will be, for example, a is x1 3, x2 1, x, we have d such vectors, d such component, right? xd. Suppose this is a, then p of yj given a is nothing but the probability, the product of all the variables ii prime belonging to a, p of xii prime given yj by probability of xii prime you add also the, you have since it's not yet in the log space, we have p of yj. This is just from the base rule again. And why do we have again two different indexes? Because here you can see that each component has so this component represents third out of the mi components, m1 components x1 can take. In the log space we can write log of p of yj given a is nothing but summation of ii prime belonging to a, p of xii prime given yj, so log of p of xi given yj divided by p of xi prime, and you have also the log of p of yj. Now if we want to instead of considering ourselves to a, suppose we sum over all possible ii primes, then we can have log of pi as it is, log of this probability and multiply it by an indicator random variable ii prime, so that this will only be true if ii prime belongs to a, which means ii prime is 1 if ii prime belongs to a, and so we can sum over all ii primes basically. Then we also have this. Now this looks awfully close to what we have in the neural network calculation for the support. So suppose we identify this as the support Sj, then we can have this part as a weight for the neural network from ii prime, or from jj prime to ii prime to j to ii prime. Then this can be the activation of the ith neuron, and then this is the uh, bias. We can see this more clearly through the neural network. So suppose say this is all the values x1 can take, and this is x2. Then we have connections like this. And suppose this is active, which means x12 is active, which means O12 is equal to 1. And then all these represent the weights. W, this weight currently is W1, comma 1 1, and this is W1, comma 1 2, and so on. And we see W1 1 2 is active and all others are 0 in the case of x1. Suppose similarly we have the first one active in the case of x2, then w1 comma 2 1 is also active. And suppose we want to verify a if a is x1 2 and x2 1 and y 1, and we can see that only when x12 is active and x21 is active, the weights are active, which will give the same probability given by this equation. Of course, we have also the bias log of p of y1 here. So what this means is we can what this representation also means is we can have x1 composing of mini columns, 4 in this case, and x2 composing of 2 mini columns. Here x1 and x2 are called hypercolumns. So mini columns are nothing but the values x1 can take, and mini columns of x2 are nothing but values x2 can take, but they correspond to the neurons in this network basically. There you have the BCPNN for one layer.